Good afternoon, ladies and gentlemen. Thank you for this invitation to give a talk about the realm of energy. We're going into energy and looking on a major paradigmal transfer of technologies and changes that will take place in the coming decades. And definitely digital services may play a very important role. In my presentation, I will touch, first of all, the question about the energy transition, very important, and then we will look on the challenges ahead for deep decarbonization. The major quest definitely is the climate change and looking on what would that mean for the energy systems. And digitalization and digital services is of course, will be an important enabler. We're looking on what we're doing already with digital services and also some visions about the future. The future looks really good and there's tremendous opportunities in the same way as we heard about AI, for instance, in the medical services. So that's the start. But let's look on the big picture and the driving force for the energy change. The driving force is definitely the climate change mitigation to get the emissions down. Here in this picture, you see with the red curve, the present trend of emissions, which is going up, and with the blue ones or bluish one, you see the pathway that we should take in order to meet the Paris Climate Agreement goal, which states that the global temperature shouldn't exceed 1.5 degrees. The gap is increasing, as you see, and or let's say it's getting constant, but it's not reducing. And this is one of the great challenges, how to really get that gap filled with the technologies, with the services and social changes, etc. Maybe the largest challenge human race ever have, of course, faced. Just by technologies, it may be difficult to fill this gap. And that's why we will, of course, in this presentation also talk about socio-technical transitions, look on what role the social system also plays in this context. And that's where the digital technologies may be very important. So the question is clear. Emissions going up or starting to stabilize, but they would need to go very rapidly down by about 40% during this decade even. And that seems very challenging indeed. So how do the international scenarios by IPCC or by the International Energy Agency, how would they view the future and how would they fill this gap? On the right-hand side, you see scenarios by the International Energy Agency, also confirmed by the IPCC, about how the electric system would change. Most of the emissions come actually globally from electricity, in particular from coal. Globally, you need to replace coal. Coal is the enemy of climate change mitigation. So get rid of the coal. And indeed, in the scenarios, you see the drop of the coal, but more amazing. And that's the big technological disruption that we perceive, is that the new technologies like solar and wind, which are completely different from the fuel-based energy system, would actually compose the major part of the change. So that by 2050, not so long from now, about 70%, 0% of all electricity worldwide would be based on solar and wind. Well, some may think, well, that's a vicious thinking. But again, if you look on just the economics of the energy, actually solar and wind are the cheapest ways to produce electricity. So it's actually economics that drive very much here the way the different energy sources change. On the left-hand side, you see some more global view on how the different technologies may play a role more in the sector-wise presentation. And I would draw your attention to the word hydrogen, for instance, that hydrogen, which is maybe slightly hyped today in many of the discussions, is also considered a very important way to produce the fuel that we have, and also to bridge some of the energy systems to have, also to store the solar and wind, which sometimes fluctuate pretty much. So finding solutions to this fluctuation that of course originates if you have much solar and wind. Most of the world scenarios show the same picture. Would that be by Shell or would that be by the European Commission, etc.? The same story, a very major change from the present type of energy system that we have. Now let's go back to today from the future and see, are there any indications of this kind of change? Or is it, again, just the scenarios? Well, interestingly, if you look on the investments in the power system during the last few years, you see by yellow and the bluish colors, these are not a political statement now, but anyway, solar and wind, yellow and blue, they dominate actually the world investments in power. So in most cases, if we take the hemisphere, it's really the wind which is the major source of power investments that we see. The new power investments go into wind, and then more in the southern hemisphere is solar. Those two constitute the major investments that we have. And so from now on, more and more of the electricity comes from solar and wind. Solar and wind, which we have very often perceived very marginal, they constitute today already more than 10%, close to 11% of world electricity, which is, by the way, more than nuclear electricity, which has been already for a long time in the market. So rapid changes and digitalization in the production processes, for instance, enables mass production, getting the price down, and scaling up rapidly. Scaling up of the technologies is the essence in energy, which is a huge commodity business. And indeed, with solar and wind, that scaling up has been very successful. So you start to see effects. And indeed, the previous scenarios shows you then what's the way from now till 2050 in the spirit of this Paris Agreement to reduce the emissions. Now, when we then just start to look more on the details on the energy change, I just draw here your attention to very recent scenarios for the European Commission in the InnoPath project, which look on the energy transition in Europe. And it brings quite interesting views, first of all, on the electrification. You will see that electricity, not just in Finland, as the chair pointed out, but also elsewhere, electricity will be actually a very important way to decarbonize energy systems. And the reason is very simple. The power is getting carbon neutral very quickly. So the emissions in the electric system is coming down. In the Nordic countries, by 2030, all electricity is perceived to be zero emission. So then using electricity for other purposes, for mobility, for heating houses, etc., industries, will be a very lucrative way to reduce the emissions. Now, in this European study, a very interesting kind of approach was look on how the different market players actually, how they react on the energy change. And indeed, if you look at the incumbents, that's the traditional energy utilities, they may use less electricity. And you see that the electric use will be less than with new players. And the new players are interesting also for digitalization because they combine the demand and supply. They don't just look on the supply, which is the typical way incumbents look, but they also start to go more toward the end user side, to consumers, households, services. And that's where the digitalization starts to play a very important role. So the new players, when they come into this energy transition, very often look on energy as a whole. And that's where we see the digital services being more important and more central. Now, all this change from a fuel-based system into a non-fuel-based, or a more weather-based, imposes a range of questions and a range of very complex problems, like the question about electrification of our society. Now, electricity is about 20% of the end use of energy. In the future, maybe 50%. Then, as you saw from the scenarios, by 2050, about 70% of all electricity can be solar and wind. And indeed, if there's no solar or no wind, how to survive those times of the moment may be important. There's a very complex conversions coming to the end use side, where you use electricity for mobility, for hydrogen production, something that the traditional energy systems would not need. And the question about the critical materials and maybe hydrogen replacing oil and fuel in the world trade. So huge and complex systems. So let's just see how we can sort out those. And we start with the energy systems changes. And now we come closer to digital services. So on the left-hand side, you see how the traditional power system works. And it's really with fuel that you feed into the power plants. With that, you keep the supply and demand in balance. If you need more electricity, let's put more fuel. If you need less, let's take fuel off. Very simple. You don't need much artificial intelligence to do that. It's very simple. But then look on the weather-based system, which is very decentralized and very data-centric. The number of different new technologies, which you may never had heard about, that's why you will need to have. All those depicted with a red color, that's new technologies, which you need to add in order to get the weather-based system to work as reliably as the fuel-based. And very often it's claimed that, well, solar and wind doesn't work. No. With those technologies that are so here, we can show it works. In many countries, it do. And of course, in our research, we can show it does. But in a way, organizing these technologies, getting those to work in a system context, need a lot of data, need a lot of thinking, need digital services. And that's where we still lack definitely those as well. There's no demand yet, but in the future, definitely we need those more. Now, where are we using our digital services for the time being? Just to see where we go in energy. So most of the digital services have been used in automation and in digital data flow, getting information from power plants or from consumers through the smart meters. That's the major use. And indeed, if we go to look, where's the least impact is in issues like blockchain, which will be very interesting if you have decentralized production and decentralized users. You can combine the suppliers and consumers through blockchain in a very effective way with, in practice, no transaction cost. And you can balance the energy system with blockchain. But for the time being, least use. But in the future, definitely very, very important. Most of the benefits of digitalization comes through efficiency improvements and cost. So cost and efficiency. That's, I would say, the driving factors for digitalization presently in the energy system. But as you see in this picture, there's a lot of different services that we can assume being more important for energy. As I mentioned, blockchain, cybersecurity becoming important, cloud computing, all that thing. So there's a range of services that we already see important for the future of energy, though there's a few dominating fields that we practice in present settings. Now, what are the elements of digitalization? I said the cost and efficiency drives the development. And we see a digital transformation from the word digital to internet and AI in terms of energy. We need to be careful is that it's not just the algorithms, it's not just the machine learning, blockchain, etc. But AI need a context. And that's where, for instance, the connectivity, 6G may be very important. You need to connect the supply and demand, and you need data. So you need the sensors, data, connectivity, and powerful computers. All that four elements, that would, I would say, constitute the AI world for energy, and why not for other fields as well. So let's not just think AI as an algorithm, but more as an ecosystem, which is very, very important, I think, when we really start to practicize the AI in the future. So from that, going a step forward to digitalization number 2, version 2, how would that look like? Slightly visionary views about the future. And I'm thinking to combine 3 radical disruptive technologies. The quantum computers, which are, let's say, in 10 years, they may be reality. Here at Aalto University, we have really good people working with quantum computers, and they say, yeah, well, we're approaching a level where a quantum computer may be 100 million times more powerful than the most powerful computer that we have. And you may even have quantum computers maybe in the future at home, so replacing your PC. And that's the vision. Artificial intelligence, we know about that. Huge development going on worldwide. China and US are leading that development. Unfortunately, Europe is lacking that. But the old initiatives, I think, is a very important addition in really to capture and fill that gap. And then we have the 6G, of course, that is all brand. All that together enables things which we never have dreamed about. And let me show some of the dreams here. And just with the quantum computers, if you think with the connectivity and with the AI software, so that could radicalize really the energy system in terms of material science, developing materials that we never thought about. I'm working also with nanomaterials, and we can functionalize, make materials with super characteristics. And through this quantum computing, through machine learning, we can really take a leapfrog in materials. Super materials for batteries, for electrolyzers, catalysts, you name it. Forecast. Our forecasts, where the forecasts are, and sometimes, maybe we can do it, forecast for a day or like 2, 5 days. Sometimes it's okay. Sometimes we make error. Forecasting will be much more accurate with these kind of solutions. And that will mean that we can actually also create digital twins to our systems. So the energy system, we have a physical system, but then we have in the digital realm we have also the copy of our system. And we can test that system in a virtual world before things happen in the real world. In that sense, we can make corrections in the real world already as we have tested our system in the future. So really going into the future, that's something that we can do and come back then to the present to make changes. For instance, if we find that there's some wind still coming, how should we react and already take that into account a day or two before it happens? All this together will also mean that when we speak about sustainable economy, I think is wrong. We need to think about a regenerative economy, taking off CO2 emissions from the atmosphere. So the concept of sustainable economy, we think it's important, definitely important, but in the future, I think that will turn much more to regenerative economy. We start to repair the nature and the damages we have done. And that will be also very, very interesting. I think this digital world that we see here now, that's a really huge opportunity for the future. Now, having said that, let me say that there's also caveats in the digital services, in particular the security. Security will be very important, cybersecurity and security of digital systems. And unfortunately, the energy field, the utilities, compared to, for instance, to banking services, lack very much. They haven't invested very much. We're looking also on some cybersecurity issues for the electric system. And let's see, but my PC have better cybersecurity than many power plants do have. So that shows that there's really a major gap which need to be filled when we start to digitalize also energy systems. And also AI, using that more for risk management will be very important. So risks is something that we need to keep in mind when we move into this very strong digital world. Now let me take at the end a few examples of digital services and how science works in that. And I'll start with energy efficiency, just to point out, I know there's a session on energy efficiency after that, but energy efficiency is really the thing that comes first. And through digitalization, we can actually keep the energy growth in if we let just things go like laissez-faire, the energy demand may in Europe increase by 40% by 2050. Then you can forget the energy transition. But if you're really conscious with all the technologies that we have, all the possibilities, lifestyle changes where digital services may be important, we could reduce by 2/3. So here again, a huge gap in the way we could foresee the future. And as said, digital services would be very important. One digital service here is an example of the demand response. So in one of our PhD works and research some years ago, we look on the digitalization to incorporate demand response. Here's a case for Helsinki. And we could see that through digitalization and demand response, we could kind of cut power demand during peak conditions by 7 to 50%, depending on conditions. And that indeed gives you much more flexibility to the energy system. If you have much solar and much wind, you can always match much better the two things here. Then the digitalization enables, in a study, we're looking also on the interaction between energy infrastructures. You start to be able to interact with infrastructures and integrate them together. For instance, think about mobility and buildings. We could use the electric vehicles. Well, we load and charge our electric vehicles very often through buildings. But we could also feed back electricity to the buildings and to the grid. So the cars could be, in a way, a balancing factor in the energy system. But that requires smart charging, smart discharging, a lot of digital services, a lot of data that you can do that. But as an example, think about Helsinki. In some years, there may be about 100,000 electric vehicles. If 20% of those could participate in this kind of vehicle-to-grid services, that is 1,000 megawatt kind of capacity, which is flexible, more than the peak demand of electricity in Helsinki today. And just pulling together a huge amount of electric vehicles would do that. Another example is that we've seen that digitalization helps really to cope with very complex socio-technical energy systems. Here's an example from China where we're looking on optimizing actually electric vehicle fields, electrical bus fleets, and using not just the battery there as the driving force, but also looking on behavioral factors like the driver behavior, the road behavior, is this rush or not, vehicle behavior, ambient behavior. In that sense, with 18 parameters instead of maybe 2-3 used before, we will be able to optimize the running time of the electric buses and also minimize the risks with the batteries and state of health. Very complex problems where, let's say, the normal science wouldn't work. And indeed, we see that digitalization is a tool where I would say the science ends, where the physics and chemistry ends. That's where it starts. And there's some example, for instance, with batteries, where you could normally use the Butler-Volmer equations to show or mass and heat and transport combined to model a battery. But when we come to very nonlinear effects, that's where the equation doesn't work properly. But there we can handle technologies like black boxes with AI, machine learning. If you have enough data, you really can model a black box. Here is an example with second life batteries. We're looking on the state of the charge and states of the health, and you really can predict much better than with any physical and chemical, physicochemical models. And finally, let me come to my takeaways, ladies and gentlemen. Just to wrap up, the key points here is indeed when we think about this deep decarbonization, which is ahead. That means radical change in the way we produce and consume energy, a myriad of new technologies compared to what we have today. And in particular, those what we call glue technologies or systems technologies will be important, where you enables us to integrate the new production technologies like solar and wind. Digital services, digitalization are critical technologies and critical services that will help to organize the new energy system. It's like the director of a orchestra, a symphony orchestra. You need a director that makes a harmonic composition of the orchestra, and that's digitalization. Very critical technologies. And finally, let's not just handle digitalization as a technical issue, but understand that in order to get those digital services into practice, we need new business models. We need to update our institutions, that is legislation, standardization. We typically have been laid down for the prevailing technologies, and also the users. The users have to be educated. So in a way, that leads to a more socio-technical realm, which we need also to take into account. So, ladies and gentlemen, with these words, I thank you very much for your attention.
Thank you very much. Do we have questions from the audience? I do not have anything here in the event tool. I have a very practical, since we are from the Perämeri, or how do you translate that in English? Rear sea. And they are planning quite a lot of hydrogen plants or hydrogen generation here due to the fact that we have several steel factories here. And steel factories are one of the big gas house emission producers. Now, what is your take on hydrogen technology? I mean, the problem is that when you use electricity to break water into hydrogen and then oxygen, you lose something in the transformation. And then when you again turn hydrogen back to electricity, there's again a transformation loss. So where are we with the hydrogen so popular that it's actually attractive?
Yeah, thank you. Very, very important and good question. And indeed, hydrogen is perceived as one of the missing links. So if the hydrogen works, it means that you can store electricity as a fuel for long times. And that's in a way solves the problems with solar and wind variability, which is indeed a question that needs to be addressed. Now, where we stand is that I myself worked with hydrogen since the late 80s, actually, and looking at the development is that we stand close to breakthrough. It's thought that during this decade, by 2030, hydrogen start to really penetrate in larger scale in some of the best regions for hydrogen. For hydrogen production, the key parameters would be, actually at present already, is the cost of electricity, which you need to feed the electrolyzers. The electrolyzers split the water into hydrogen and oxygen. And it may sound now slightly suspicious, but let me say that, for instance, the cost of solar, the cost on the market, is among the cheapest in Europe. And the wind power cost that we have in Finland, because of very good engineering, is the lowest in Europe. So they have the cheapest wind. And they say, sometimes I'm suspicious that they say that even the wind, if you look on the large scale applications, is among the cheapest. So that's first precondition that is filled there in the Aalto region that there you have. Now, about the losses, indeed, always with chemical conversion, you have a loss there. And one of the tricks to make hydrogen in some way, let's say, really competitive is to use the waste heat that comes out. So you have to look on integrated systems where you can employ the heat, for instance, for district heating or for industrial processes. Otherwise, you start to lose too much on the efficiency, or let's say overall energy efficiency, and then comes the cost down. Now, in case of the northern Finland, northern Sweden, where this kind of a first large hydrogen hub in Europe is planned, and actually now European Commission is supporting this pre-planning of that. The hydrogen would be used as a raw material for, as you said, this iron reduction in steel industries. And that's where the let's say the efficiency gains would be the best. You don't have so large losses there. Going forward of that, indeed, then the next step is really to start to use more the waste. But interesting times by 2030. That's where the thought is that there would be a major breakthrough.
Okay.
The leading countries in hydrogen is, unfortunately, not Finland, but it's Denmark, Holland, Germany. And if you look at the project there, we speak of very large-scale projects where hydrogen starts to really penetrate into the society. So this is maybe the new technology that we have. A lot of uncertainties, no question, but a lot of interesting opportunities as well.
Yeah. Any further questions? Okay, there is. Our next speaker wants to ask you a question.
Okay.
Thank you for your excellent presentation. Before going actually to my next presentation, I wanted to know your vision and your, let's say, guess about the future of digitalization of energy systems. My question is about we know that in the digitalization of energy system, for sure, we need some kind of data sharing and maybe intelligence sharing between operators. Not only the data from the customer side, the data from the operators, TSO and DSO, should be somehow shared. And we already know that they are conservative about their data. They want to have their data in their local, let's say, data platforms. And if they don't share this data, maybe if they do sharing their data, maybe we come up with some more innovative data-driven services. My question is about that, how they can encourage to share. It's just a matter of some kind of regulatory push or some kind of new business models need to be developed in digitalization to encourage them to share data and intelligence among them? Thanks.
I think this is a very extremely important question in the sense as data is one of the most important resources that we have in the future. Energy is important, but data may be even more important. And data is the basis for the new services that we see here. And indeed, for that reason, I think many of the market actors that we have, they keep the data by themselves, which from the whole system point of view, if you look at the whole system, often leads to suboptimal solutions. So what to do? As you said, regulatory changes may be that you regulators enforce open and of course you can't reveal your business kind of let's say plans, but anyway, go for more open data, which could be enforced by the governments, or then of course the collaborative arrangements that we see already among some of the utilities here. I think we are at a very early stage yet in this question, but I think to address that now properly will be important. Let me say that Europe lags as a whole in terms of data openness compared to US and in particular to China. China has a huge population, a lot of data, and can make use of that as the regulatory environment is very, very positive. And I think the regulatory environment in the US is much more positive. And this is something that I think Europe is at present also thinking about as data is so important for all these transitional digital services. So I would expect maybe rather that maybe if I would guess, I would think that regulatory environment may change and that may ease then the openness.